This is Dr. Rajakannu, Amuthakkannan. Today we are going to see about control charts for variables, which will come under the topic of statistical quality control techniques. What is meant by control chart? A graph having data on y-axis and time on x-axis with upper control limit and lower control limit is called control chart. Sir, what is mean by upper control limit and what is mean by lower control limit? We are going to see in this video. It was originally developed by Walter A. Sheward. Control chart is a means of monitoring variation in the characteristic of a product or service. Types of control chart. What are the different types of control charts? There are two categories. One is control chart for variables. Another one is control chart for attributes. So what is control chart for variables? Variable control charts are used to evaluate variation in a process where the measurement is a variable. One particular variable we are able to measure means by the time we can draw the control chart for variables. The variable can be measured on a continuous scale. For example, height, weight, length, concentration, temperature, speed, pressure. These are all we can measure in a continuous scale. This is the reason these things we can draw using a control chart for variables technique. Different types of control charts. X bar chart and R charts are there. X bar chart and S charts are there. Moving average, moving range charts is there. Target charts are there. Cumulative sum control charts are there. Exponentially weighted moving average charts are there. And in attributes, there are variety of control charts. What is meant by attribute? Attribute means countable data. Attribute chart means what, sir? Attribute charts are a set of control charts specifically designed for attribute data. Attribute data means we can count the data. For example, number of defects. Number of defects in an automobile component, if we are calculating, one count data will come. For this, it is possible to draw a control chart. This will come under the category of control chart for attributes. Even number of defective. How many number of defective components are there in a sample? We can count. Then we can draw the control chart for attributes. There are different types of attribute charts. C chart, it is meant for defects. U chart, it's meant for defectives. NP chart, we can use it for number of defective and sample size. P chart, we can use it for percentage of defectives. This one we can say in another word, fraction defective. Upper control limit and lower control limit. What is this meaning? You see here, 3 sigma. We have to take a process average, then we have to allow a 3 sigma limit to add with process average to find upper control limit. We have to subtract 3 sigma from average value of the process, and then we can find the lower control limit. So process average plus 3 sigma, it will give upper control limit. Process average minus 3 sigma, it will give lower control limit. Sigma means what, sir? This is standard deviation. Steps to use control chart for quality control analysis. We have to find averages. Then we have to find upper control limit and lower control limit. This will vary for different charts. Plot the points of given data. Observe the trend of variation. Then we have to find the process capability to understand whether the process is in control or not. Then we have to check if the process is in control or not. Then we have to analyze using the cause and effect diagram. Then we have to analyze and find the cause for change of pattern, whether it is matter of concern related to production department or design department. Then we have to find the remedy after coordinating with the concerned people. Then we have to give some suggestion to take appropriate action. So we can do statistical process control using control chart. Why we are doing this statistical process control? Statistical process control is tool of SQC, statistical quality control, used to predict and fix the variation affecting the product or processes. It checks the data of past and present, understand the ongoing present system, and also takes corrective measures to obtain controlled system for present or nearby future. How to build a variable control chart? Here we are going to concentrate X bar chart and R chart. The example is given like this. A machine is working to a specification of 56.58 plus or minus 0.05 mm. Samples of 5 heads were taken at regular intervals and measured. The result of measurement of 5 subgroups are given below. It's given subgroup and samples. We have taken 5 samples here and also 5 subgroups here. The question is construct a control chart and find whether the process is in control or not. Calculate the process capability index. The solution, how to do that. You see here the subgroups, it's given 1, 2, 3, 4, 5. We have taken the samples 1, 2, 3, 4, 5. Initially, we have to find the average of X bar. We have to add these values. Then we have to find the average by dividing 5. The same manner we have to find for the second, third, fourth, fifth average X bar. Then we have to find the total sum of X bar. Then we have to do the range. How can we find the range? What is the maximum in this sample? Maximum will come 56.62 minus, what is the minimum here? 56.54. What is the difference? 0.08 will come. So this one we have given here. Similar to that, we have to find what is the maximum in the second subgroup and what is the minimum, and we have to find the range. It will come 0.05. Then we are finding the range. Similar manner, we have to find in the end what will be the sum of the range, the total of the range. After that, we have to find X double bar. You see here how to find the X double bar. Sum of X bar, it has come here 282.972. The number of subgroups, how much the number of subgroups? It is 5. So we are going to divide by 5. Then we will get 56.5944 mm. Then average range of the sample. See here we have found sum of R. Then sum of R divided by number of subgroups. Sum of R, it is coming 0.31. Divide by 5. It will come 0.062 mm. Then we have to find the control limits for the range chart. Sir, how can we find the control limit for range chart? To find upper control limit, D4 into R bar. To find lower control limit, D3 into R bar. Sir, what is D4 and what is D3? There is a table for control chart constants, particularly for this X bar and R charts. It's given here. The subgroup is 5. You see here the subgroup is 5. A2 value, A3 value, D2 value, D3 value, D4 value, B3 value, B4 value, it is there. So this particular place we are going to take it for the 5. You see here D4, if we take, see there, D4 for the subgroup 5, it is given as 2.114. So 2.11 we have taken. D3 it is given as 0. So D3 we have taken here as 0. Then we can calculate R bar, we have calculated already as 0.062. Then D3 into R bar, it will come. The similar to that, D3 is 0 and R bar is 0.062 into 0, then it will come 0. Similar to that, we have to find for the X bar chart, upper control limit and lower control limit formula it is given. X double bar plus A2 R bar, lower control limit X double bar minus A2 R bar. So X double bar it is already calculated. A2 we have to take from the chart. After taking A2, we have to substitute here. It is coming as 0.58. Then all other values we are having, X double bar we are having, R bar already we have calculated. If we substitute here, you will get 56.63 as upper control limit for the X bar chart and 56.56 is the lower control limit for the X bar chart. Then we have to draw the X bar chart and R chart. First, we have to take X double bar. How many number of subgroups? 1, 2, 3, 4, 5. This we have to take it in x-axis. Then we have to take one scale here. Then what is the average X double bar? 56.59. And what is the upper control limit and what is the lower control limit we have to mark. In between that, we have found already the average X bar. The average X bar we have to mark the point here. Then we have to join all the points. Then you will get the X bar chart. See, for example, the first point is 56.578. We are going to point 56.578 here. Then similar to that, we are going to point all other X bar values. Then we will get X bar chart. Then R chart, how can we draw the R chart? Similar to that, R bar you have to identify, then you have to draw as center line. Then upper control limit and lower control limit we have to draw by taking subgroup as x-axis and R value as y-axis. Then we have to take the R value, range value for the subgroups from the table we have calculated. Then we have to draw the R bar chart. No points are going beyond upper control limit and lower control limit in X bar chart and also in R chart, and this is the reason we can give the comments. From the X bar chart, we can understand that all 5 samples are within control limit and the points are lying near to the center line. Comments on R chart, the R chart is drawn and all 5 samples are within the control range. Then how can we calculate the process capability? Process capability index CP equal to upper specification limit minus lower specification limit divided by 6 sigma. Upper control limit and upper specification limits are different. Upper specification limit normally it will be given in the problem. See here 56.58 plus or minus 0.05 mm is given. 56.58 plus 0.05 is upper specification limit. 56.58 minus 0.05 is lower specification limit. So we can calculate the upper specification limit and lower specification limit for the process capability index, and 6 sigma we have to calculate. How can we find the sigma? Sigma means standard deviation. For the standard deviation there is a formula. So R bar already we have calculated. R bar is equal to 0.062. D2 we can calculate from the table. D2 is there here. and we can find it out for the subgroup 5. So D2, it is coming as 2.326. So we are going to take 2.326 from the table. Then we can find it out sigma. Then process capability 6 sigma we can calculate by multiplying with 6. Then upper specification limit, lower specification limit, we know that. Then we can find the process capability index for this problem. It is coming as 0.641, which is less than 1, greater than 1, equal to 1. There are some meaning in process capability index analysis. Here CP is less than 1, the process is wider than the specification limit. CP is less than 1 means it is not acceptable. So we have to study the process to improve. Process is out of control. Even though X bar chart and R chart is within the control, process capability index shows process is out of control. Hence, some defective parts and products are made. 100% inspection is required in this production batch. We have to improve the process in this particular problem. Thank you for watching this video. I will catch you in another video.